We got it. Yeah. Let's go. Keep change. Flip, 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 keep change. Flip. New objective, the goal is dividing fractions. Take this lesson and put these methods to action. Right. First step, if you see a mixed number fraction, take the necessary steps to change it to improper fraction. Then you keep the first fraction the same.
Say what?
Then you keep the first fraction the same.
Say what?
Then you keep the first fraction the same.
Say what?
Then you keep the first fraction the same. Change that division sign to a time sign. 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 Flip the last fraction. 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 Multiply like you know you should.
Okay.
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 Keep change. Flip, 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 keep change. Flip. What's up, scholars? This is Mrs. Finney with Lyrical Math, and this is our track tutorial for our song, Keep Change, Flip. This track covers the math concept for dividing fractions, and what you just heard are the steps to procedurally solve for dividing fractions. The learning objective for this song is for you to practice reciting and memorizing those steps so that you can divide fractions at any time. Let's get started. Keep change, flip, keep change, flip, keep change, flip, keep change, flip. New objective, the goal is dividing fractions. Take this lesson and put these methods to action.
Right.
First step, if you see a mixed number fraction, take the necessary steps to change it to improper fraction.
What?
Then you keep the first fraction the same.
Say what?
Then you keep the first fraction the same.
Say what?
Then you keep the first fraction the same.
Say what?
Then you keep the first fraction the same. Change that division sign to a time sign. 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 Flip the last fraction. 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 Multiply like you know you should.
Okay.
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 Keep change. Flip, keep change. Flip, keep change. Flip, keep change. Flip. All right, let's check out a problem so that we can put these methods to action. Here we have 4 1/5 divided by 1 2/10. So if we listen to the lyrics, it says, new objective, the goal is dividing fractions. Take this lesson and put these methods to action. First step, if you see a mixed number fraction, take the necessary steps and change them to improper fractions. So here we have what's called a mixed number fraction because we have a whole number with a proper fraction, and that would be considered a mixed number fraction. We also have another mixed number fraction here, and we want to change those to improper fractions. Improper fractions are when the numerator would be larger than the denominator. Example, 9/4 is an improper fraction. The numerator is larger than the what? Denominator. Let's do another one. 7/2 is called a what? An improper fraction because the numerator is larger than the denominator. All right, so we want to change our mixed number fractions to improper fractions, and we do that by multiplying the whole number to the denominator. That's 4 times 5, which gives us 20. Then we take that, add it to the what? Numerator. So 20 plus 1 is going to give us 21. So we're going to write 21 over the same denominator, 5. Bring the division sign down for now. And we're going to change this next mixed number fraction to an improper fraction using the same strategies. So we want to do 1 times 10, which gives us 10. take that and add it to 2. 10 plus 2 gives us 12. So we are going to write 12 over 10. Notice both of these are called improper fractions because their numerators are larger than their denominators. All right, let's continue with the lyrics. New objective, the goal is dividing fractions. Take this lesson and put these methods to action. First step, if you see a mixed number fraction, take the necessary steps and change them to improper fractions. Then you keep the first fraction the same. Say what? Then you keep the first fraction the same. Say what? Then you keep the first fraction the same. Say what? Then you keep the first fraction the same. What we're going to do is keep the first fraction the same. So 21 over 5 is going to stay 21 over 5. All right? Next part of the lyrics say, change that division sign to a times sign. 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 Very simple, right? Next step, flip the last fraction. 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 What does that mean? We're going to change 12 over 10 to what is called its reciprocal, 10 over 12. All right? So let's think if we had 7 over 5, the reciprocal would be what? 5 over 7. If we had 9 over 3, the reciprocal would be 3 over 9. Challenge somebody that you know and see if they can give you a reciprocal of 7 over 10. All right, let's get back to our work. So we're going to change 12 over 10 to its reciprocal, which is what? Did you say 10 over 12? Celebrate good times. Come on. All right, we're going to put this as 10 over 12. All right, next set of steps say multiply like you know you should. Okay, 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 so we are going to go back to our lyrics from our song, Please Don't. Think about those lyrics. Those are our lyrics for multiplying fractions. In those lyrics we hear, please don't dump me because I know what's happening. Turn my mixed numbers into improper fractions. We don't have to do that here. How did we do that? Multiply my whole number to the denominator, then I take that and add it to my numerator. Okay, cool. We are going to do the next step. Cross divide diagonal numbers by their GCF. Let's take a look at the diagonal numbers. We have 21 diagonal from 12. You see that diagonal? Diagonal, right? We're looking at the factors of 21 and 12, meaning the numbers that multiply together to give us 21 and the numbers that multiply together to give us 12. All right, we're going to start with 1 times 21 gives us 21. I want to try 2. 2, there's no whole number multiplied by 2 that can give us 21, but 3 times which whole number gives us 21? Did you say 7? Bring down the confetti. Let's go. So we have 3 times 7 is 21. What about the factors of 12? We have 1 times 12. What about 2? 2 times which whole number will give us 12? 2 times 6. How about 3? 3 times 4 will give us 12. So these will be considered the factors of 21. These will be considered the factors of 12. All right. Now we're going to look at the other diagonal numbers. What are the other diagonal numbers? 10 and 5. Factors of 10, we have 1 and 10. And 2 times which whole number? 5. Perfect. And 5 only has 2 factors. 5 is considered a prime number because it only has 2 factors, and the factors are 1 and 5. All right, so now we have our diagonal numbers paired up, and we have all of their factors listed. What we need to do is cross-divide diagonal numbers by their GCF, meaning we're going to look for the greatest common factor because GCF stands for greatest common factor. GCF stands for what? Greatest common factor. Perfect. So, what is the largest number that you see on this side as well as this side? Did you say 3? You're rocking with me? And I can see you're smart as can be. Let's circle 3, let's circle 3, let's circle 3, let's circle. All right, so cross-divide diagonal numbers by their GCF. 21 divided by 3 is going to give us 7. 12 divided by 3 is going to give us 4. Let's look at the other diagonal numbers. 5 and 10. GCF will be what? The greatest common factor of 10 and 5 is, drum roll. Did you say 5? Outstanding. All right. So what we're going to do is cross-divide diagonal numbers by their GCF. 10 divided by 5 gives us 2. 5 divided by 5 gives us 1. Replace them with the quotient. That's the answer to the division problem. Then I do the rest. Next, multiply my numerators. So 7 times 2 is going to give us what? 14. Then I multiply my denominators. 1 times 4 gives us 4. Last part of those lyrics, I take that answer, then I simplify it. Meaning, we're going to look at this answer and see if we can simplify it. Yes, we can. If our answer is an improper fraction, meaning the numerator is greater than the what? Denominator, we're going to divide the numerator by the denominator. So over here, we're going to use this space for 14 divided by 4. How many groups of 4 can you get out of 14? Look at your answers to your 4 times tables, starting with 0, 4, 8, 12. Just make sure you don't pass 14. And we would have to stop here, which is 0, 1, 2, 3 groups of 4 gives us 12. So divide, put the number on the top, multiply, put the number on the bottom, subtract. We have nothing left to bring down, so that is it. The number at the top is the number of groups, so we had 3 groups. The number at the bottom is the number we stopped at. 3 groups of 4 gave us 12. 14 minus 12 gave us 2. Start at the top, go around the clock. So we end up with 3 and 2/4 as an answer, which can also be simplified. So if you look at your answer and you notice that there is a GCF of the numerator and the denominator, even though it's not an improper fraction, this is considered a proper fraction when the numerator is smaller than the denominator. If you can divide both of them by the GCF, do so. So in this case, I'm thinking of my factors of 2. What are the numbers that multiply together? Give me 2. 2 times 1. Factors of 4. What are the numbers that multiply together? Give me 4. 1, 4, and 2 in itself. So their GCF is what? 2. All right, so when I look at this, I'm looking at their factors, and I just noticed that their GCF is 2. So in this case, I'm going to divide both the numerator and the denominator by 2 to get my actual final answer. That 3 whole is still going to be there. All right, so this becomes 3, and 2 divided by 2 is 1. 4 divided by 2 is 2. So technically our answer is 3 1/2. We are done. New objective. The goal is dividing fractions. Take this lesson and put these methods to action. And we just did it. Let's go. Thank you so much for joining me for this track tutorial. I will see you on the next track tutorial. Scholars, keep up the great work. Peace.